Hello, in this presentation I would like to introduce the field map technology. So if we look to some definition, what is it field map? So we can say that the field map is a software and hardware technology for computer aided field data collection and data processing. Field map combine flexible real-time GIS software with electronic equipment for mapping and dendrometric measurements. So the main tasks for the technology is convert data from the real world to some database and GIS layers. So the technology is collected from hardware and from the software. So the hardware has different parts. If we speak about the hardware, so there is a core of the system is a field computer or tablet computer running a full version of Windows, and on this computer is running the field map software. And then there are some additional electronic devices used for data collection and data measurement. So typically it's a laser rangefinder and inclinometer combined with electronic compass. This tool is used for measurement of distances, heights, position of trees in polar coordinate system. Other typical device is GPS, or now is not only American GPS but also the other systems, so GNSS with global position and global coordinates. Then there are some accessories like tripods or monopods, poles, reflectors, carrying cases, and so on. And field map can connect also other electronic devices like electronic caliper, electronic poles, dendroscopes, and other devices. So the hardware can look very differently, depends on your project. So if you require very high precision, then usually is use some theodolites or some systems based on some relative angle measurement and very precise laser rangefinders. If the precision is not required in millimeters, let's say, so then is fully sufficient some standard laser rangefinder with decimeter precision, decimeter accuracy, and so on. So you can have the technology on the tripod or on the monopod. So for inventory, usually is use a monopod because you can very easily relocate the technology to other position and continue the measurement. So some key functions of the field map. So the field map has a fully flexible geodatabase with GIS support. So you can have an unlimited number of different plots. So each plot can be in different coordinate system. Each plot can have unlimited number of GIS layers, typically points, lines, and polygons. Each layer can have many different attributes, standard attributes like numbers and strings, lookup place, up to some geomedia or media formats, pictures, voice records, videos, and so on. So field map use industry standard data formats. Usually the local database is in Firebird or Microsoft Access, and for server synchronization is use MS SQL or PostgreSQL database. So the database can be customized anytime without data loss. So you can start collection, and then when you realize that there is missing some attribute, so you can add this attribute and continue data collection. And we believe that the software is user-friendly, the environment and very easily can be developed any project for data collection. So we believe that the software or the technology is useful for foresters and researchers, and they don't need any programming skills, so they can prepare the design of the database very easily without any programming knowledge. On the other hand, there is functionality for scripting and data programming and some script programming. So there is a powerful scripting engine where you can write in Object Pascal your own scripts. So the scripts can be simple scripts like controls or some simple calculations, or it can be very advanced scripts for some graphs or parameterization and so on. So you can also program your libraries in other systems and then connect from the field map to your own program. So it passes the data to your program and then return back. And in field map are also some built-in features for data analysis and data processing and pre-processing, or processing and pre-processing. So the field map is for developers, programmers, and for analysts. So from beginning, the field map was developed for the National Forest inventories. The first project was in Czech Republic, National Forest Inventory, and this project had 18 teams. So from beginning we developed functions for this multi-plot approach. So then you can split the project between many teams and then combine back the data collected in the field. So there is some functions for management of the data, and we believe that this system is very powerful for projects like forest inventory. Then there is the support of different measurement devices. We already spoke about it. It's a GNSS, laser rangefinders, compasses, electronic encoders, calipers, and other electronic devices. In field map are import and export functionality, especially the batch import function allows to create the field map project from your already existing data. So if you have say inventory or some project collected with the traditional technology, and you have the data in Excel or Access, so you can prepare some profile and import entire data to your field map database and use this data for a repeated measurement. So it's very useful if you repeat the collection of data. So then you already have a position of trees, you can have data like species and previous diameter and so on. So the data which do not change, or you want to see what was before and you want to compare how the tree is growing and so on. So all these features are prepared in the field map. And of course there are many functions for simple layer import and export of data to Excel or to other formats. If we speak about general mapping features, so the field map support all three GIS layers, point lines and polygons. You can use any background map compositions which combine raster and vector formats. You can also use web map services as a background map. Each plot can be in different map projection. You can even in one project combine plot in local coordinate system and in global coordinate system in your map projection. Very important function is a continuous positioning for navigation and for mapping on the plot. So for example, if you have a circular or a square inventory plot, so you don't need to measure everything from the center of the plot, so you can freely move to any location on the plot where you can see at least one point already existing in the map and the point you are able to recognize in the forest, and use this point for positioning, for your repositioning, and continue mapping from other location. So the field map is suitable for any type of mapping. Then there are some special forestry features, so there are special layers, trees and deadwood. So these layers are combination of the basic GIS layers, like tree is combination of points and polygons. So the point is represented center of the tree, and polygon of basal area, polygon of crown projection, crown profile or stem profile. The same with deadwood. So the deadwood is combination of horizontal line and crown and polygon of the horizontal projection of the deadwood. So the field map is useful for forestry projects. So there is also some special layer called transect for vertical visualization of the trees on the inventory plots or research plots. A very useful function for especially for multi-team projects is server synchronization. So in forest, in field, we always work with a local database, so you don't need any internet connection for data collection. But once you come to office or to internet connection, so you can the new data transfer to the server, and if there are some new data on the server, this data can be downloaded to your computer, and like this you can synchronize data with the server. So each team can synchronize with the same server, and on the server you will have all data, and each team will have only those plots which you decide for that particular team. The synchronization can be used not only for synchronization of collected data, but also for the metadata, for the structure of the project. So for example, you are a developer of the project and you realize that there is missing some attribute or some item in the lookup place. Let's say some species was missing in the lookup place, so you can add it in the office to the list and send this new lookup place to the server, and all field teams next time when they will synchronize with the server, they will download this new lookup place or the new structure of the project to their computer, and this data, this new metadata will be available for collection. Field map support two types of server databases, MS SQL and PostgreSQL database. In some project, field map can be also useful for aerial point photo classification, where you have some area, cover it by point grid in some density, let's say 10 per 10 meters in this example, and then you define some hotkeys for each point, and very quickly go point by point and decide if this point, for example, is forest, broadleaf forest, conifer forest, or if is it meadow, or is it urban area, and so on. So like this you can very quickly create the grid of or classified grid of points, and from these points you can create the polygons, and this data can be used as a background for some stratification of the area, and then for the inventory, so you know what area is forest, what is not forest, and then you can do inventory only in the forest area, and so on. So the field map software is not only one software, so it's a group of softwares or programs and some special libraries and tools. So we can split it to four groups. So center part of every software or of every field map software is a database. So you can decide what type of database you want to use. And then there is a first part is a preparation. So there is a software field map project manager. Using this software you can design your project based on your methodology, so you can add the layers, you can add attributes and lookup place, and so on. In the preparation phase we also count some tools for field map sampling. So if you have, for example, inventory plot and you want to do some stratified random sampling, so there is a special extension for this task. And also import of data, so you can use some functionality in this phase to import data. So then there is the implementation part. The most important software is FieldMap Data Collector. So this tool is used, or this software is used for any data collection. So the data collection can be used, can be done manually by finger, by pen, by keyboard, or by electronic devices. So any input of data is in a data collector. In data collector is also engine for scripting for developers. So this function can be later switch off for standard users, so then they don't have access for your scripting, but the developers can develop the scripts directly in the data collector and test it immediately if it is working properly and so on. And there is also a tool for database querying. So if you want to do some searching in database, or you want to prepare some data for export, you can do it in this database query tool. So then there are some group of tools for pre-processing. So there is a special software called FieldMap Stem Analyst for modeling of volume and assortment. So typically it's used in countries where there are not available volume equations or volume tables. So you can do some measurement of stem profiles and prepare your own volume equations using this tool. Also there is some extension called FieldMap KNN, so the K nearest neighbors for calculation of increment. And then the last part of the or last group of the software is for processing, and there is software FieldMap Inventory Analysis for statistical data processing. So there are many tools for classification, reclassification, aggregation, stratification, and also for statistical processing. And as a result, you can get graphs and table with some confidential interval and so on. And also there is some tool for printing of maps, so FieldMap Printer. So you can the maps in local system or global system, whatever map you prepare in data collector, so you can prepare for printing and use that tool, FieldMap Printer. So some example projects and references how the FieldMap can be used. So one big group of users is large scale forest inventories. So typically it's national forest inventories. At this moment we support 10 countries for national forest inventory. Each country have slightly different methodology, so they use it a little bit differently. So they have different size of plots and grid and so on, and also collected layers and attributes. And so FieldMap can consume all these different methodologies and can be used for the inventory. So then there is some small scale forest inventories. Typically it's forest inventories in national parks. In Germany, for example, is used in many national parks and biosphere reservation for this small scale forest inventory. So the principle is very similar like the national forest inventory. Usually it's not collected so much attribute like in national forest inventory, but the principle are very similar. Carbon stock monitoring is focused for above ground biomass, and also below ground biomass can be calculated, but for this of course you need some equations which can be implemented in FieldMap using scripting, and then after a measurement on plots you can immediately calculate the carbon, and this carbon can be then certified and used in many projects. Landscape mapping is another type of project where you can do mapping of some area using GPS. Typically it's using GNSS or GPS, where you measure the polygons and describe these polygons for mostly for universities. Is used some field map for some research plots where the students or PhD students mostly do some detailed study on the plot, where they do measure all trees, regeneration, even 3D model of the forest, and can study how the forest develop in time. So they repeat it after a few years and study. So all the functions are there for it. Biodiversity monitoring, so it's another type of projects where data are collected on the transect, and this is usually very complex projects where there is many different specialists for fauna, flora, trees, and so on. So all the data are collected in one database and then used for additional reports and presentations. Stem shape volume model, so we already spoke about the stem analysis. So it's a function for developing volume equations or volume tables, and these results can be used for volume calculation of your project. Forest tent mapping and attributing is a different type of project. So like in some countries, for example in Czech Republic, we have to prepare forest management plan every 10 years. So the forester go to forest and describe what is there, prepare the plan for next 10 years, the harvesting, planting, and so on. So everything is prepared in the field map database, and then can be using another extensions directly connected to the field map. Can be print forest maps and forest books for the forest owner and forest authorities. Wood tracking is another type of field map usage. So it can be used mostly it's in tropical countries, like in Peru. Is used for tracking of the forest, starting with the inventory of the valuable species, and then harvesting and tracking up to the sawmill. In the database are recorded each location of the wood, who was the person who cut it, and who transfer and when, and so on. So everything can be tracked in the database, and then automatically create reports or some important documents for government directly from the field map. Another example is mapping of hydrology. So for example with field map you can even measure a 3D model of the river, because we measure the height of the reflector, and if you are on the boat you can locate the pole to the bottom of the river, and when you measure to the reflector, so field map automatically calculate the Z coordinate of the bottom of the pole, and like this you can measure many points, and then using some spatial analysis you can make a 3D models of the watershed or whatever. So at this moment this field map used in 42 or 43 countries in the world, and 10 countries use it for the National Forest Inventory. So it was a brief introduction of the field map, and thank you for your attention. Bye bye.